Hey everyone, and welcome back to The Explainer. Today, we're going to tackle a super common challenge in data science. How do you predict a simple yes or no? You see this everywhere, right? Is a customer going to buy something? Is an email spam or not? These are binary choices, and they need a special kind of tool. So let's dive right in.
A lot of us are used to building models that predict a number, like forecasting how much we're going to sell next month. But a choice isn't a number you can just count up. It's a category. You either do the thing or you don't. And that is a totally different kind of problem that, you guessed it, requires a totally different kind of approach.
So here's how we're going to break it down. First, we'll get a handle on the problem itself. Then, we'll see why some of our go-to models just don't work here. After that, we'll get into the really cool solution, the logistic function, figure out what it's telling us, and then we'll even check out a completely different way to think about the whole thing.
All right, first things first. Let's get really clear on what we're trying to do. This isn't about predicting how much money someone might spend. It's about predicting if they'll spend it at all. That right there is the heart of a classification problem.
Okay, so let's imagine a scenario. Say we run a website, and we want to figure out which of our users are most likely to upgrade to a paid, premium account. And for our data, we've got two key pieces of info: their salary and their years of experience. The mission is to build a model that takes those two things and gives us a simple answer: paid or not paid.
So we have our problem set up. Now, for a lot of people, the first instinct might be to grab a familiar tool from the toolbox: linear regression. I mean, it's great at drawing a nice, straight line through data points. But is a straight line really the right tool for a yes or no question? Let's find out.
And this slide really gets to the heart of the issue. See, linear regression is built to predict continuous things, like a price or a temperature, that can just keep going up or down forever. But for our problem, we need to predict a probability. And probabilities have one very, very strict rule. They absolutely have to be between 0 and 1. 0% and 100%, no exceptions.
A straight line has no idea about that rule. It doesn't care. So if you have a user with a really, really high salary, a linear model could totally predict a probability of, say, 1.5, which is like a 150% chance. Or for someone with almost no experience, it might spit out a negative number, like negative 20%.
And at the end of the day, those numbers are just gibberish. They don't mean anything in the real world. You can't have a 150% chance of doing something, and you definitely can't have a negative chance. So a model that gives you those kinds of answers isn't just a little off, it's completely nonsensical. We need something better.
And this brings us to the hero of our story today, the logistic function. This is the clever bit of math that lets us take that unruly straight line and bend it into something that actually speaks the language of probability.
So this thing, the logistic function, you'll also hear it called the sigmoid function. It does one very special, very useful thing. It can take any number you throw at it, it doesn't matter how huge or how tiny, and it just squishes it into a nice, neat value that's always between 0 and 1. It creates this beautiful, gentle S-shaped curve. And here's the really brilliant part. We don't have to throw away our linear model. We can still use it to figure out how things like salary and experience are related, but then, instead of using its output directly, we just pipe it through the logistic function. And what comes out on the other side? A perfectly valid, sensible probability. It's the best of both worlds.
Okay, awesome. So we have a model that actually works for our problem. But what can it tell us about our users? This is where we need to learn how to read the model's coefficients.
So when we train this logistic regression model, it gives us these coefficients for each of our features. So for example, here, both years of experience and salary have positive numbers. What does that tell us? It tells us that as either of those things goes up, so does the probability that a user will have a paid account. Simple as that. It's not just a black box, it gives us real insights we can actually use.
So, logistic regression is amazing when you want to estimate the odds, the probability of something happening. But sometimes you don't really care about the maybe. You just want a decision, yes or no. And this requires a totally different way of thinking, which brings us to another model, the support vector machine.
Just think about this for a second. If your only goal is to draw a line in the sand and sort every user into either a likely to buy bucket or a not likely to buy bucket, do you really need to know if they have a 73% chance versus an 85% chance? Or can you just find the absolute best dividing line and call it a day?
And that's exactly what a support vector machine, or SVM, is all about. Instead of modeling probabilities, it thinks about the problem more like a geometry puzzle.
It looks at all the data points for our paid users and our unpaid users, and its entire goal is to find the single best boundary to separate them.
Now that boundary has a fancy name, a separating hyperplane. So what makes one boundary the best? Well, an SVM defines it as the line that creates the biggest possible gap between itself and the nearest data points on both sides. It's basically trying to draw the widest, safest street possible between the two neighborhoods of data, which makes the classification super robust.
All right, so let's do a quick recap. We saw that linear regression just isn't built for yes or no questions because its outputs can go wild. Then we brought in the logistic function, that awesome S-curve that tames those outputs into nice, neat probabilities. We learned that logistic regression's coefficients can tell us how different factors affect that probability. And finally, we saw that there's a whole other way to look at it with SVMs, which are all about finding that one perfect dividing line.
And that brings me to a final question for you. Think about the data you deal with, or the problems that you find interesting. Where are those hidden yes or no questions? It could be anything. Customer churn, medical diagnoses, you name it. These classification models are powerful tools for getting answers.
And that is it for this explainer. If this helped clear things up for you, do me a favor and hit that like button, share it with a friend, and definitely subscribe for more deep dives just like this one. Thanks so much for watching.